In this video, I wanted to talk about how systems work, and this is systems as related to entity component systems. And in a previous video, I have introduced that an entity is sort of something with an ID, and components are something, I'm going to say that they're just a bag of data. It's an object with a key, with key and values. And the key is usually something like a component name, like shape. Hey, this is a shape and it's an object that looks like what? Maybe you want a name. It could be, we could call it primitive, and that's box, and it might have some parameters like params, and it might be something like size. It's 5 meters long, 5 meters tall, 5 meters wide. So that's the entity and component. And then I said that everything else was in the system. So this is going to actually draw or cause a side effect to actually draw a box in our HTML5 canvas and render that on the screen for us. So system, we can say, is the implementation, it's the behavior and everything. So we also introduced a global object called the XRS window object, and this takes a list of systems currently. You can register a bunch of these foundation systems, so you can register system, and just for kind of completeness, you can unregister them, although there isn't any use case for it yet, but potentially maybe in a big world you're entering a space where maybe you need like a new effect, like some music thing, and you only need it in that room. You could register it there, and then maybe when you leave the room, you don't need that extra code running in the background for processing musical notes if you're in a place that isn't going to use that ability. So you could unregister that system later. So you notice that XRS as a foundation just calls some setup function in system, and it doesn't actually do anything on its own. It's really just a container or a facilitator for this. Oh yeah, there's one other thing you can do. You can say create entity, and you can delete entity. Okay, so that means that if we want to communicate from one browser to another, the XRS system can't really help us. We actually need to add new functionality via a system. So one interesting system that I would like to introduce is called the broker. So system broker is responsible for making a WebSocket connection. So WebSocket connection allows us to communicate with a server, and we do this with Phoenix channels. So let's take a quick look at that. It's broker. Here it is. There's the file. And up top, every system is going to have a setup function. We're going to get a reference to the XRS in case we need to traverse the XRS to get to some other system. We can say XRS dot get system, and we could reference some functionality that we need from some other system that we don't have. And XRS keeps all of its variables and state inside context, so in case we need reference to that. But here's that bit of Phoenix socket, WebSocket, and channel business. So we create a new socket. We're getting a token from the backend, which we pass right back. We get that in the browser, and we'll pass that back so that we kind of eliminate any man in the middle. So some third party that didn't get the token from the server won't be able to create a connection. And then we set up some listeners. So here, this code may require some more time to introduce some concepts. For now, this is something that introduces something called Signal Hub, which is an event-based. Just think of it as a pub subsystem. It has channels of its own. You can have incoming and outgoing. It's not a Phoenix concept, but I will introduce. It's using RxJS, and I'll introduce that in a future video. But for now, let's say that the broker sets up a channel on that socket. Now, this is a Phoenix concept, and you can have multiple channels. Right now, we just have a space channel. So the channel, you can think of it as a pub sub topic. So you're gonna say, I'm subscribed to this channel XYZ, and then anyone else who's connected to channel X, Y, and Z, we can receive each other's messages. And so what this broker does is it's listening on our own internal pub sub, which I said was a signal hub, and it will receive incoming, there's two channels, one outgoing and one incoming. So you can post something, you can put a message into a channel called outgoing. And so what this broker does is it listens to the channels on outgoing and it pushes those messages out onto that WebSocket channel. It then goes to the web server out there, and then the web server can run its own logic and decide to broadcast that message to other browsers. So that's how you get messages like, oh, something was created. Remember I said that the messages are going to look something like this. Entity created, entity deleted. So, and then some data to go along with it. So we would say outgoing, emit, entity created, and then some payload containing the ID of the entity, containing the components of the thing that's being created. So as that goes out, it's received by the server and it goes to all the other browsers. And what do they do with the message? Well, because they also have that foundational system called the broker running in their respective browsers, and they're connected to that same channel, they will receive something on the channel. And so there's another local pub sub thing that is receiving and then posting it on incoming. And so you can react to that. So you could say when entity is created. So this is the flip side of this. So you can send messages out for entity created on the outgoing channel, and then you can receive messages incoming on the incoming channel for the same messages. And then here you can subscribe to it and then do some side effect. And the side effect we opt to go for usually is to call something on this XRS object, and then we can call its internal functions, create entity, and then pass it along the whatever components. And that at this point, because the systems are registered with the XRS, when we process and loop through each component name that looks like this, shape and box, we then get an opportunity to access that system of the same name and then create some behavior and add it to the entity. And so that is kind of the nuts and bolts of what a system does. So system is a kind of interface. So here's the full range of methods that the system class could have. Every one of them does some whatever initialization they need to do in setup. They could subscribe to some pub sub, listen for, did you click something? Did you press a key? Did you grab something? All that kind of stuff. And then they could potentially react to it. But this is kind of at a system level, and sometimes we want to react on an object level. After all, this shape thing is unique to a particular entity, right? It's a box over here, it's a sphere over here, it's a whatever over there. So when we receive the message coming in on Signal Hub, we process each component individually for an entity. Let's go ahead and look at how our XRS object does that. So when we're processing the create entity message, we'll upsert components, and upsert components is really just a convenience method for add a component or update a component, of course, which is implemented on the entity object. And here it is. So it will call update component will, underneath the hood, after you look up the system, will call update behavior, passing in this entity and some component data. Remove component will call system remove behavior, passing in this entity and add component will add behavior. So these methods are implemented here. This add behavior, update behavior, and remove behavior. Passing in the entity you want to remove it from, and then data that you're injecting or updating. And so a system needs to implement these. We can look at another system. So we looked at broker, which brokers are not components, because this is a service that is system-wide, so it's a new ability, but you're never going to add a broker component on any entity, unlike the component shape. So shape, not this one, shape, here we go. Shape implements those methods on a per item level. So system shape extends this base system with behaviors, which is a way of implementing more of these with a base class. So this area here doesn't take up as many code. And then I have this abstraction called the behavior. And so by creating a behavior, we can push some of that functionality into this behavior class. So every time we add the component on an entity, instead of having all of these methods implemented on, well, they still are implemented. The add behavior, remove behavior are implemented on the system, but they just delegate that into a new instance of the behavior. So here, behavior shape passing in this system will be tied to this this entity. So let's take a quick look at how that would work for the shape component. So suppose somebody sends this message: create entity with shape here. When it's finally received by XRS, it's going to say add component, and then so we get the system name shape, and then we'll call add behavior. So then here's shape. Sorry, not this one. There we go. Yeah, this one. So it's looking for an add behavior here. So if we look at base system with behaviors, here it is, add behavior. We'll build the behavior, so we'll implement a shape behavior, and then we'll call that behavior add. So that goes to this instantiated class here, and it'll call add, and then finally it'll call create mesh. So this pattern here is just a little bit more object oriented. Otherwise, you would have a class here that's sort of keeping track of all entities that are for a system, and this just pushes more of their state into this behavior object here, so it can keep track of its arbitrary state on its own, but more or less is similar functionality. So that's probably maybe a little confusing, but if you kind of look at this code, it's just a wrapper around Babylon's mesh builder, and so it can recognize a certain number of strings, like creating a box, a sphere, cylinder, etc., and it will just take some options, and we just pass that straight through to Babylon's mesh builder, and that's what will finally render that onto the screen. So so more or less these systems kind of do the same thing. So we're able to create an API on top of Babylon.js things for things like transform, and then if you update the message, or if you update the component through messages, we just underneath the hood call Babylon.js's API and transform those things. But we can also create APIs or systems for things that Babylon.js doesn't have. For example, we can include maybe Tone.js for music, or maybe some machine learning APIs for TensorFlow.js, which would allow us to bring in almost any kind of JavaScript code, wrap it up into a system, and then be able to send messages and have the broker system delegate messages to XRS and then call the update behavior, add behavior underneath the hood, and that's what's triggering systems from messages. So this was a very quick and fast overview of systems and how they're related to the components, how they listen to the data, and how message passing is invoking those functions on the systems as it relates to the data that those systems care about. So hopefully that made sense, and I'll explain more about RxJS and this in the PubSubs stuff in a future video.